We are now moving on to the next chapter in the Math 12 curriculum, and which is chapter number 7, and chapter number 7 deals with probability. So for the very first lesson, we need to understand what is probability. And to start off with the chapter, we need to define a few terms, outcomes and events. So when you perform an experiment, there is a set of outcomes that you can expect. Example: if we roll a dice, we could expect numbers like 1, 2, 3, 4, 5, and 6. Remember, a dice has 6 sides, and each side is numbered. Now, when we look at an outcome is basically the result from a single trial of an experiment. Okay, so the outcome is just a result. Now, events are different from outcomes. Events include a desired outcome or a set of outcomes from an experiment. Okay, so the key thing is events include a desired outcome. So what I mean by that is if I'm rolling a dice, I may be looking for a situation where I'm rolling just an even number. So the event of rolling an even number could be 2, 4, or 6. Or I could have a different event where I want a number less than 5. So when you have a dice, you have 6 numbers, and I could look for a number that's less than 5. So the numbers that are less than 5 are 1, 2, 3, 4. So there they are, 1, 2, 3, 4. Or I could look for a prime number. So from these 6 outcomes here, the prime numbers are 2, 3, and 5. Or I'm looking for a situation where I'm rolling a 4. So these are all examples of events. Now, another definition that we need to learn is sample space, and this is simply a list of all the outcomes from an experiment. And we'll definitely look at sample space when we do a few sample problems. All right, now let's look at experimental versus theoretical probability. Probability, the likelihood or chance that an event will occur, ranging from 0 to 1. 1 meaning that it has a 100% chance of happening. Experimental probabilities are based on the results of actual experiments and will vary all the time. All right, so these are when you're doing a lab. For example, if you're looking for the number of heads that can happen when you toss a coin 5 times, that's an example of an experimental probability. And every time you do that experiment, I guarantee you will have different results. So when flipping a coin 100 times, what is the experimental probability of getting 60 heads? So you can have anything from 0 to 100 heads. It's highly unlikely that you'll get 0 heads, and it's also highly unlikely that you'll get 100 heads, but the point is you need to actually do the experiment and find the results. Now, theoretical probability, these are based on calculations. So here's probability. So probability will simply be equal to the number of desired outcomes divided by the total number of outcomes. And for Math 12, we will definitely do a lot of calculations here, so we will do a lot of theoretical probability calculations. Another type of symbol that you may see is PA, and this means the probability that event A will occur. And we'll see this again in the next slide. All right, so theoretical probability. PA. This is the probability that event A will occur. If PA equals to 0, this means that event A is impossible. It will never happen. If PA equals to 0.5, this means there's a 50% chance that event A will happen. So 0.5 in terms of a percentage is 50%. If PA equals to 1, then the event will certainly happen. All right, so for 0.5 and 1, those represent percentages as well. So you just take 0.5 and times it by 100 to get 50%, and 1 times 100 will give you 100% as well. All right, let's look at outcomes now. How many outcomes are there for each experiment? Drawing a card from a deck. rolling a dice twice, and drawing 2 cards from a deck with replacement. Okay, so if you're drawing a card from a deck, there are 52 cards in the deck excluding jokers. So there's basically going to be 52 outcomes. Now, what are the outcomes when you are rolling a dice twice? All right, so if you're not sure what that would look like, you need to create a chart here. And I'll just show you a simple chart over here. So if you're rolling one dice, you have 6 outcomes, 1, 2, 3, 4, 5, and 6. And if you roll a second dice, you will also have 6 different outcomes, 1, 2, 3, 4, 5, and 6. Now, if you roll the 2 dices at the same time, you're going to have several different outcomes. For example, the first dice could be a 1, and the second dice could be a 1. Or the first dice could be a 1, and the second dice could be a 2. So this is a second outcome. A third outcome might be, the first dice might be a 1, and the second dice could be a 3. And if you follow this pattern here, you go all the way up to 6, where the first dice is a 1 and the second dice is a 6. So if you consider all the different outcomes, you actually have a grand total of 36 different situations. Another example is the first dice could be a 6, and the second dice could also be a 6. So we have 36 different outcomes when we're rolling 2 dice. Alright, now let's go back to the outcome sheet. So when when you're rolling a dice twice, there we have 36 different outcomes. Alright, example number 3, drawing 2 cards from a deck with replacement. Alright, so with replacement, we can create 52 times 52 outcomes. So we'll have 2,704 different outcomes. So basically how this works is you have a deck of cards. There's 52 cards. And the first time you go into the deck, you have 52 different choices, right? So that's how you get the first 52. Once you pick that card, since it's with replacement, you put it back into the deck. And for the second time when you go into the deck and pick a card, you still have 52 different outcomes. So that's how you get this second 52. So you would multiply those two numbers together to get 2,704 different outcomes. And when you're multiplying here, you're just applying the fundamental counting principle. Alright, so Jack flips a coin 100 times. How many heads will he get? Alright, so we can do this 2 ways, theoretical probability and experimental probability. So if we're looking at the theoretical probability here, the probability from a single trial is 50%. So when you flip a coin, you have a 50% chance of getting a head or a 50% chance of getting a tail. So you do have a 50% chance of getting a head from a single trial. So the probability of a head would be 50%. Now multiply that by 100 trials to get the number of heads. So in 100 trials, we will have 50 heads. So if you calculate this mathematically, using the probability of 50%, and if you flip the coin 100 times, then the chances are we'll get 50 heads. Now for experimental probability, experimentally there could be 0 to 100 heads. So if you do this, if you try to do this on your own and flip a coin 100 times, you could get 0 heads, or you could also get 100 heads, or anything in between. So when you do the activity, get the class to flip a coin 100 times and find the number of heads, and chances are everyone will have a different answer. All right, let's move on. Let's look at a few more let's take a look at a few more probability examples here. A card is chosen from a deck of 52 cards. What is the probability of getting each of the following events? So what's the probability of a king, the probability of clubs, the probability of a red card, and what's the probability of getting a face card? All right, so let's bring out the standard deck of 52 cards right here. Question number 1, what's the probability of getting a king? Well, I have 1 king here, 2 kings, 3 kings, 4 kings. So I have 4 kings, and there are 52 cards in the deck. So the probability of a king would be 4 kings divided by 52 cards, so 4 over 52. And if you reduce this, so this will be 1 over 13. So you have a 1 in 13 chance of getting a king. All right, so what's the probability now of getting a club? Well, here are my clubs right here at the bottom. We have 52 decks, 52 cards in the we have 52 cards in the deck. 13 of them are clubs, so the probability would be 13 over 52, which is approximately 1/4. All right, next one. What's the probability of getting a red card? All right, so if you look at my standard deck of 52 cards here, I have red cards over here, and I have red cards over here in the form of hearts. So half the cards are red and half the cards are black. So we have 52 cards. We have 13 cards here and 13 cards over there. So 13 plus 13 is 26, which is roughly half of 52. So 26 divided by 52 is 1/2. And for the last example here, what's the probability of getting a face card? All right, so the face cards are my jacks, my queens, and my kings. So I have 3 face cards here. Then I have 3 face cards there, 3 over here, and 3 over there. So 3, 6, 9, 12. I have 12 face cards out of the total 52 cards in the deck. So 12 divided by 52 is simply going to be 3 divided by 13. All right, so that concludes the very first lesson in chapter number 7, what is probability? And we'll see you again in the next video.